search for reality. The modern science 400 years back in the western part of our globe started the journey to search for reality. It was a scientific revolution initiated by Newton and Descartes. The objective is to find out whether there is one fundamental reality from where this whole creation has emerged. And to investigate this, they developed a new methodology of modern science. What features this methodology of science is to form a hypothesis and design an experiment, conduct the experiment, and observe all changes that occur very meticulously, and conduct the experiment again and again. And if it gets repeated, then you conclude, you infer that this is hypothesis proven. This is the methodology of science that was evolved. The best of the intellectuals from all over the world, started working in this direction to search for reality the scientific way. Soon, Newton and Descartes found that this world is very, very complicated. We do not understand how even an object just falls down. We don't know how the lightning occurs, how the thunderbolt comes. What to talk about things like gods, goddesses, devils, pishachas and others? No, it's all beyond our capacity. So let us start things which are very simple, down to earth, concrete things of this world. Once we complete understanding of this thing, then we'll go to the more subtle and causal dimension of our universe. This is how science started. And breakthroughs after breakthroughs. Today, we are in a fortunate position after 400 years that we know almost everything in the physical world. In search for reality, we wanted to find out from where the whole universe has come. What is that source? To find out the structure of this physical universe, we started finding out. And today we know that every object is made out of molecules. What are the molecules made out of? Atoms. And atoms, protons, neutrons, electrons, fundamental particles. Very, very, very subtle and small particles. And what are they made of? They are all made out of energy. They are called as quarks. Therefore we know that everything in the physical world is nothing but energy. And we can precisely calculate how much of energy is in given matter. The famous equation, E equals mc square. E is the energy, m is the mass, and c the velocity of light. What is the velocity of light? 186,000 miles per second. If a light ray starts here, in 1 second, it will have 300,000 kilometers away in 1 second. Put that number, it will be a very huge number. For example, if I convert this small piece into energy, it can burn up 50% of our entire Bangalore city itself. Such is the immense amount of energy packed into so-called inert matter. And we have been able to use this for destruction in atom bombs. When we convert them into useful energy, we have the nuclear reactors to generate energy. The process of fission reactors as they are called. Therefore we read today, everything in the world, physical, is nothing but energy, energy, energy. Now, what are the laws that govern this physical world? We know that for normal speeds, They are governed by laws of motion found by Newton. All of you know about this Newton's laws of motion. 3 laws of motion. And this entire set is called as classical mechanics. That means everything here is classical. What does that mean? Everything is determined. It is also known as the deterministic approach. There is no ambiguity. If, for example, if I leave an object, after 1 second, we know it is 32 feet down. If I launch a rocket in a particular direction in a particular speed, it goes on and you can trace the entire trajectory towards the moon. No ambiguity. Everything mathematically precise. And this is why it is called deterministic approach. All of us have studied the 3 laws of motion in our high school days. What are they? Law number 1. It says a particle continues to be in its state of rest or of uniform motion unless it is disturbed by an external force. If you don't have an external force, it will continue moving like this or stay where it is. This is law number 1. Newton found out this, therefore it is called Newton's laws of motion. What about the second one? Second law of motion. All of us are familiar. Force is proportional to mass and acceleration. F equals ma. Depending on the force, your acceleration, the rate at which your particles move, will become more or less. If you have a tremendous force, it will go very fast. If you have less force, it will go slowly. Also, it depends on the mass. If the mass is very huge, same force, it will take you slowly. If you have a small mass, it will go fast. So this is law number 2. And law number 3, very important. Action and reaction are equal and opposite. Depending on how much force with which you throw a ball to a wall, it is going to come back. Greater the force you throw, come good fast. Action and reaction are equal and opposite. Depending on your action, the reaction also gets controlled. A simple example. I take a ball and throw it to the wall and the ball comes back. If I hit with a greater force, it is going to come back with greater force. This is law number 3. Therefore, depending on the mass and with the force, you will be able to trace the entire trajectory as to how it is moving towards your goal, say moon. Precisely you can calculate. It is all mathematically precise. Therefore we call this as deterministic approach. This is all for normal speeds. But when you go to extremely high speeds, like an electron swirling around the nucleus, nearing the velocity of light, then these 3 laws will not hold. We have to go for new set of laws. They are called quantum mechanics, special theory of relativity, and the deterministic collapses. What do I mean? We know in the classical mechanics, if I leave the object, everything is determined. Whereas in the subtle world of subtle particles, it is different. If I leave an electron here, electron can come down, electron can go up. It can go to the front, to the back, to the right, to the left. In fact, an electron spreads like a globe. Therefore, you cannot say where exactly will be the electron after I leave the electron from here. It can be here, it can be here, it can be in that corner, or it can be far away there. Determinacy collapses, the death of determinacy, people have written. Then how to do that? we only talk of probability. The probability to find the electron after 1 second here is 10%. Probability of finding the electron far away in that is 0.1%. This probability can be calculated. For that, mathematical equations are available. That is the Schrödinger equation. Therefore, we have mathematically precise ways to calculate the probability function. Therefore, this entire gamut is called the probabilistic mechanics, quantum mechanics. And that is how the whole set of equations describe the whole motion in the normal speeds and in the extremely high speeds. So we know both the structure and the laws that govern this physical universe. Everything is nothing but quarks, energy, and the laws of Newton for normal speeds and the quantum mechanics for extremely high speeds. So we are in a fortunate position. We have been able to understand the whole spectrum of this physical world. What is it made out of and what are the laws that govern them. Therefore, anything physical, we have been a big success. Putting man on the moon, building skyscrapers, underwater tunnels, information technology, and very powerful pharmacological interventions, and very sophisticated surgeries. We have 5,000 types of surgeries. You can replace every part of the body today. Everything is physical. Therefore, anything physical, we have been a big success. That's where we stand today. After 400 years, therefore, we are in a fortunate position that we understand everything about the physical world. Then what next? In early 70s, people thought that we had reached the end of the game. There is nothing else to know. But soon came that wonderful book written by Professor Fritz of Capra in early 80s, which sold in millions all over the world. What did he do in this bestseller? He traced the entire history of modern science, how it started from Newton and Descartes, how we unraveled the laws that govern them and the structure, and what are all the changes that brought forth in our life, how the life became more comfortable, and what are the challenges that we faced, everything. And then he said, remember what Newton and Descartes said, after completing the understanding of the physical world, we have to go beyond the physical. We are in that transition. We are in that turning point. Is there something like prana? What is it that we call as mind? Into this region of subtlety and causality, we have to move, he said. It opened up the minds of people, and the scientists started investigating things beyond the physical. Understanding this entire world, having completed understanding of the physical world, we are moving towards the subtler and causal dimension of this world. In that we are in a very embryonic stage. Over the last 40 years, hardly we have touched the fringe of the problem. Except to talk about consciousness here and there, we have not made any major change, major understanding as well. But what is the way out? It's here that the top scientists of the world, including Fritz of Capra, believe that India has the solution. And they believe that Upanishads can give the directions to modern science. Whether it is Fritz of Capra or Professor Josephson, Brian Josephson, who was the youngest Nobel laureate in the world. At the age of 29, he got his Nobel Prize for Josephson function. He says that Upanishads give the direction. How is it possible? The ancient scripture, thousands of years old, can give direction to the most modern science with all such tremendous growth of science and technology? It looks impossible. So, what is that secret that the Upanishads unraveled is the question that we take up now. Thank you all very much. Dhanyavad.